This is it, the end. 10.5, all about surface area and volume, okay? So a couple of shapes that I need you to know about, like rectangular prism, cube. That looks like about it. So what a prism is, guys, is basically it is a three-dimensional shape that is made up entirely of polygons. Polygons are any shape that is closed and has no curves, okay? And it must have three sides or more. So when we're talking about prisms, just to kind of show you some pictures of those, all of these that you see in 1 through 4, those are prisms. Those are prisms, okay? Because they're made up of entirely nothing but polygons. In fact, 1 through 4, it's made up entirely of nothing but squares and or rectangles, okay? So 1 through 4, those are prisms. So let's talk about its surface area. Actually, that's like the last thing that we should be talking about. We should be going back to volume. I'm on the last slide. My bad. But we'll talk about that here in a second. So volume. So we have a couple shapes that we need to talk about volume on. And again, prisms is one of those. And the volume formula for a prism is big B times H. Big B times H. Okay? What big B represents means, I believe I had this over here in the notes. Big B represents the area of the base. All prisms have a base shape. So if we go back and let's take a look at these guys again. So in this picture, the base shape is this guy that's down there around the bottom, which is 3 by 3. So that means the base shape of this prism is a square. If we look over here, here's the base of this shape. It's a 3 by 5, so it is a rectangle. The rectangle is the base of that shape, okay? Down here, you can see the base of this shape. It is a 4 by 4, which means that this base shape is a square. And again, over here, you see the base of the shape. It is a 5 by 5. So the base of that shape is a square, which is why we had to do 10-4 first, because big B means find the area of a base. And in this case, when we look at these 4 examples up here, the bases that we're working with are finding the area of a square or finding the area of a rectangle, which we just did in 10-4. Okay, so prisms are big B times H. After that, we could talk about it as a cube. So a cube is a special prism because a cube is like a die that you roll, okay? Cubes, all cubes are, is just made up entirely of nothing but squares, okay? That's what a cube is. Every face, every polygon in it is a square. So again, if we look back at these, this one is not a cube because all the lengths are not the same. Because if it was a cube, every face would be a square. It means every side would be the same. Again, over here, this is not a cube because every side length is different. Okay, well, except for these two. But again, it's not a cube because to be a cube, you got to be nothing but squares. If you look down here, all side lengths are the same. So that means every face that you see in here, every side of this prism is a square. That's a cube. Every number in here, every side length is the same. That means this thing is a cube. So every face is a square. Okay? So again, if you want to find the volume of a prism, take the base area times the height. Okay? You want to find the volume of a cube, that's S cubed because all side lengths are the same. So just take one of the side lengths and cube it. Another way that you usually think about area of a prism that most of you know, length times width times height. And if you look right here, that length and width, that's what we would call big B, because that's like the base area. But again, that length and width times height, that really is for the prism known as the rectangular prism, because the base of the rectangular prism is usually a rectangle, hence the length and the width. Okay? Just kind of giving you some heads up and some information about some of these formulas that you've seen. So the next one that we want to talk about is what we call the pyramid. And what's cool about the pyramid is that pyramids are prisms in disguise. Pyramids are prisms in disguise. Okay? To find the volume of a prism, a pyramid is basically like inside a prism. If I give you a prism, so like for instance, inside these 4 prisms that are up here are really 3 pyramids. There are 3 pyramids stuck inside each one of those prisms that all have the same the same volume. So if you want to find the volume of one prism, you take and divide by 3, which is why the 1/3 is there. So this prism or pyramid formula comes from the fact that inside a prism, there are 3 pyramids that are all the same. So if I want one prism, all I have to do is take this and divide it by 3. That's where that formula comes from. Because there are 3 pyramids inside one prism. To find one, you just divide it by 3. Okay? Pyramids, if you don't know what they look like, they're like prisms, but they come to a nice Sharpie point. Think Indiana Jones. Okay? Prisms come to a nice Sharpie point. All right? So, if you imagine 3 of these pyramids are actually stuck, 3 of these guys are actually stuck inside here, and they all have the same area, which is really cool. Volume. So if you want the area of just one of these, volume of one of these guys, stuck on area for some reason, if you want the volume of one of these guys, take a prism and cut it by 3. Okay? So there's all different pyramids. Okay? So next, the next solid that we want to talk about is the cylinder. All the cylinder is a prism in disguise. But we don't call a cylinder a prism because it has curves. Because prisms have to be made up of polygons. And that's the same thing for a pyramid. Since a pyramid comes out of a prism, pyramids have to be made up of all polygons. And if you didn't notice that my pyramids all up here are all about triangles, and then you have that bottom shape, which is what we call the base. Okay? So pyramids are all made up of triangles except for your base shape, whatever that might be, the bottom of the pyramid. Oop, that's the, so a cylinder, again, it is a prism in disguise, but cylinders, the top and bottom of it, are made up of circles, which is why you see the pi r squared there. Because what's the area formula for a circle? Pi r squared. And so, as I said, a cylinder is just the prism formula in disguise. Big B times H. But again, we just talked about this. The big B is all about the area of a circle, which is pi r squared. So we just substitute it in. So that's what you get here. To find the volume of a cylinder, pi r squared H. Because this guy right here represents big B. Okay? And then last but not least, if you want to find the volume of a cone, the volume of a cone is just like the pyramid formula. If you look at a cylinder, I know it's weird to think about it, but inside this cylinder on number 9 and number 10, there exist 3 cones. So all you have to do is divide it by 3, and you get the volume of 1 cone. And that's what is underneath here. Oh, I forgot I had 2 other ones down below. Let's cover that back up. Didn't mean to spoil the surprise. So a cone consists of the volume formula of 1/3 big B, which is our pi r squared, H. It is the pyramid formula in disguise. Okay? Just like the cylinder formula was the prism formula in disguise. And then last but certainly not least, we will have the volume formula for a sphere. The volume formula for a sphere, which is 4/3 pi r cubed. So 4/3 times pi times r cubed. Now let me tell you where this comes from, because it's really interesting. It's really cool on how this works. Basically, some things that we know about a sphere is that in order to get the volume of a sphere, it's made up of all sorts of pyramids that cover the sphere. Let me show you what I mean. I got a nice little picture of it over here. So here's a sphere, okay? And inside that sphere are all these different pyramids. And if we find all the pyramids and add them all up, you get the volume of a sphere. Okay? So that explains why in our formula over here, you see this division of 3, and although you can't quite tell it here, you get a pi r squared. Okay? Because again, we have all these cones that are inside my sphere. So you now understand where the pi, the 1/3, and at least the r squared come from in there. But the thing that I got to talk about is, where is this 4 coming from, and why is this cube? So that means that there's an extra r coming from somewhere, right? So, well, first off, since we're talking about the, the volume of a cone I don't know why I circled cone. It should be a pyramid, because there are pyramids inside there. Silly me. But again, you can kind of see where some things are coming from, because the volume of a pyramid is 1/3 big B h squared. Let me go back. I just made a whole mess of that. I'm sorry. I didn't mean to confuse you on that. But it's all about a pyramid. Regardless of anything, I'm correct about that. So let me take this pyramid formula and tell you where things are coming from, okay? Because that was my fault. I totally just circled the wrong formula. I know I confused you. Let me backtrack for a second. I'm going to show you this picture again, okay? So in here, you can see 4 different pyramids. There's this little guy right here that goes down there. There's this little guy right here that goes down there. There's this little guy back there. There's this pyramid that's back there. So here's where things are coming from. And you can see one of these pyramids highlighted for you, where the base is right here. That's that giant square. And the height that's on the inside there is the radius. So let me show you some things. In a pyramid, one thing I need you to know, this is a horrible pyramid, but I'll go with it. So here's a pyramid. In a pyramid, where that height is coming from, and the same thing for a cone. There are actually 2 heights on a pyramid and 2 heights that are on a cone. Let me backtrack for a second. Anything that is dotted means that it is behind the shape. You can't really see it. So technically, these guys over here should actually be dotted, because technically we can't see those lines. Okay, because that's behind the shape. All right? So in a cone and on a pyramid, there really are 2 kinds of heights. Remember, heights connect down to a side and are perpendicular. Okay? So keep that in mind. So one of our heights is right here. Another one of your heights is right here, that's along the outside. Okay? On a pyramid, one of your heights is right here. Drops down into the center and is perpendicular there. Another height is along the side here and is perpendicular. Let me tell you the difference between these 2. And here's how you're going to think about and how you will know which height you need and which one you don't. Think of this as Indiana Jones. Indiana Jones is right here at the top of my pyramid. Indiana Jones can do one of 2 things on this pyramid. He can drop inside, right down into the middle of a pyramid. This is what I refer to as the actual height of the pyramid. when Indiana drops down inside of the pyramid into the pit of snakes. And he's always like, snakes. Why did it have to be snakes? So this is the true height. And it's perpendicular down here. I know that it said it had to be perpendicular to his side. Well, it is. It's perpendicular to the base, which is a side. Okay? This guy that's out here is when Indiana Jones is in trouble. He sees the Nazis coming up the other side of the pyramid, and he has to escape really quickly. So he's going to slide down the side of the pyramid. When Indiana Jones is sliding down the side of the pyramid to escape from the Nazis, this is what we call a slant height. And we usually use the letter L for that, for slant. Okay? So, when we're talking about these volume formulas, the true height for pyramids and for cones is the drop that is down into the inside of it. So over here, the true height of this cone is right here. This is Indiana Jones dropping down inside the pyramid. The height that is along the side of the pyramid, where he is sliding down the outside, that's what we call a slant height. We don't want to use a slant height, okay? We want the blue line that's on the inside. So up here, how this is, what we need this for, is when you look at this pyramid that's right here, this R is Indiana Jones dropping into the pyramid. So if I relate this pyramid back to that formula, we know that the height on the inside is R. Okay? So if I come back here, and we know that this sphere is all about pyramids, so we know that we have 1/3 big B times H, which we just talked about what H was. H was an R. Okay? Because that's Indiana Jones sliding down inside the pyramid. And all those heights of those pyramids are going to be a radius, because all those pyramids are starting from the center and sliding out to the surface of those pyramids. Now, where does the rest of this information come from? Where's the 4? Where's the pi? Where's the other R that completes the R cubed right here, or the other R's? And that's what big B is about. Remember, big B is about the base area. But what is making up the base of my pyramids here? Well, all these bases are a part of the surface of the sphere. Think about it like a baseball. The surface of the baseball is the covering that covers it. Okay? That if you took the stitching apart and you took off the cover, that right there represents big B. So our big B in this case is represented by what we call the surface area of the sphere, because that's all the bottoms of the pyramids. It's along the surface of the sphere. And it's not in here. You don't need to know it. But again, I'm telling you this because I want to explain where these formulas are coming from, because it's fascinating. It's interesting. The surface area of a sphere is 4 pi r squared. And remember, I just told you that big B represents the surface area. So if I take this green formula right here, the pyramid formula, and my surface area formula, and I put them together, you get 4/3 pi r cubed. That's where that formula comes from. It's a combination of the surface area and a pyramid formula. Okay? Very interesting. And again, what's also interesting, since we're talking about surface area of a sphere, remember how I said that baseball analogy? If I take a baseball and cut off the coverings, what you see right here, look at this little formula. That means area right there. That's the area formula of a circle. Pi r squared. That's the area formula for a circle. The 4 in front means that in order to cover a sphere, you need to make 4 circles. That's interesting, that the surface area of a baseball, or any ball in particular, is 4 circles of the same area. Pretty cool. And the surface area, or excuse me, the volume is just the surface area of all those little pyramids that exist inside my sphere. Pretty cool. So again, I'm just telling you where these formulas come from. The goal of this section, I think it's interesting to know where the formulas come from, personally, because, you know, sometimes we as math teachers, we just say, hey, here's this formula, know it. Well, where's this formula coming from? It's usually my question. Where is that coming from? Why do I know that? Why is that true? Here's where they are true. This is why those formulas work the way they do and why they're written the way they are. Okay? So, again, on a note card, if you do not know these formulas, this is stuff to put down on a note card. Because, again, in your guys' exam, on your test, on your quizzes, in your homework, I'm not giving you these formulas. So you need to know all these formulas. Formulas for a sphere, cone, cylinder, pyramid, and prism. Know these volume formulas. Because all we're going to do now is I'm going to give you shapes, and you're going to start finding the answers for me. Okay? So this one, again, we've done a problem like this. Back in 10.1, although I didn't think I jumped right into this, but I guess I do. Okay? Back in, not 10.1, but 10.3, when we did perimeter, with a formula like this, because it looks like you are trying to find how much it will cost to haul some dirt away. Okay? So again, this is just like what we did in 10.3, and we did a problem like this in 10.4, so we're just going to do it again. Again, remember, it was a 3-step process. So let's talk about that process again. Step number 1, we need to find the volume of whatever we're looking for. Since this is in 10.5, it's all about volume. So what is the volume? So if we look at this, it says you are about to build a swimming pool. Okay? The hole is 90 feet long, 60 feet wide, 6 foot deep. If you think about swimming pools, generally their shapes are prisms. Okay? So what you're looking at is a rectangular shaped swimming pool, a rectangular prism to be more specific. So this is what your swimming pool looks like. And it is 90 feet long by 60 feet wide by 6 feet deep. So the first thing you're going to do, find me the volume of this. So it's a prism, right? So the volume formula for a prism is big B times H. So again, big B represents base area. What is the base that we're dealing with? What's the shape at the bottom? So what is that shape? No, it's not a parallelogram. This is a rectangular prism. What is that bottom shape? It is a rectangle. So in order to find big B, we first need to find the area of a rectangle. This is what represents big B. What's the area formula for a rectangle? Little base times height. So if I look at this guy, again, up in here, that's a right angle because it's a rectangle. So one of these sides is little b. One of these sides is h. So if I plug in, what's 90 times 60? And that gives you 3,600. No, excuse me. God, it's been a long day doing math. It gives you 5,400. Okay? That's the area of the base. So we take this and we plug it in up here. Now this H right here is all about the height of the three-dimensional shape. You got two different H's up here. This is the height of the base, which is a two-dimensional shape. This height right here is the height of the solid, the three-dimensional shape. So up here, that's the only other number that we really haven't used. This number that is right here is the other h. It is the height of the three-dimensional shape. So what we need to do now is we need to take our big B, which is 5,400, and multiply that by 6. Or in other words, let's just finish this out. So 5,400 multiplied by 6. I'm going to have to go to my calculator to do that because I don't do that in my head. 5,400 times 6. There's the volume of my pool. 32,400, and I believe we are in feet cubed because volume is all about cubes. Okay? Volume is all about cubics. So our volume, again, 32,600 feet cubed. So your labels for volume are cubed. Let me make sure that that was indeed the number, 32,400. So again, I wrote it wrong, so got to make sure that I write it correctly. 32,400. There's the volume of our pool. Okay? Or, again, if you recognize this as a box or a rectangular prism, you could have done length times width times height. So take 90 times 60 times 6. It's all the same. Because when you multiply the 90 and the 60, that's big B. And then when you multiply it by 6, that's taking big B times the H. It's all the same. But that's really how the formula works. So again, we found the volume. But if you look up here at the problem, it tells you that you hire a truck that has a capacity of 10 yards cubed. Okay? 10 yards cubed. So we need to figure out and convert this information from feet cubed to yards cubed. So that's what that second step was all about. We need to convert. Not covert. Silly me. Convert. So we got to figure out feet cubed to yards cubed. And again, this is where you go back to those conversion notes. And specifically, you'll want to look at page 3. Because, you'll want to look at page 1. And on there, you'll see a formula. I thought it was on page 1. Nope. Oh, I remember what's going on in this one. So if you look on our conversions, you actually won't find a relationship between feet cubed and yards cubed. So I want to show you something. I want to talk to you about something. So we can create actually lots of conversions that don't exist for us. So for instance, I want to show you some things. Let's talk about feet to yards. If you look on your conversion, we definitely have a feet to yard type idea. We know that 3 yards is equal to, 3 feet is equal to 1 yard. And this is all about perimeter, since the labels are not squared or cubed. Down in the next set of English system conversions, you see another relationship between feet and yards. But this time, it's feet squared and yards squared. And you see that feet squared is 9 feet squared to 1 yard squared. How do you think I can, and this deals with area because we're talking about yards that are squared and feet that are squared. Any label that's squared is all about area. How do you think I can convert from perimeter to the area ones? What happened to those? Is there any way that I could take 3 and convert it into a 9? Any way that I can take 1 and convert it back to a 1? Think about the labels. Those labels are squared. And if you look at it, there's a relationship between perimeter and area. If you have a perimeter relationship, if you square it, you get the area relationship. Pretty cool. So all those ones in here, like for instance, we have a relationship that says 1 foot is equal to 12 inches. There's a perimeter relationship. What would the area relationship be? What would feet squared be equal to in inches squared? Well, all we have to do is square this relationship right here. What's 1 squared? 1. What's 12 squared? 144. And if you actually look on our conversion sheet, you can see that relationship. Again, in that second column of English system area, you see that 1 foot squared equals 144 inches squared. Now look at this. And let's see if I can get you to make the right conclusion. We now want to talk about feet cubed, yards cubed. Do you think that there exists a relationship between the perimeter and the volume? Take a guess as what you think these numbers are going to be. Try it. So, if you guessed 27 and 1, you are correct. Just like the area was about squaring because your labels are squared, if I know the perimeter relationship and I cube it, because volume is all about cubes, I get the volume relationship for those two measures. Because 3 times 3 times 3 is 27. 1 times 1 times 1 is 27. If you look on our sheet, we do not have a relationship of feet cubed to inches cubed, but we can make it. All we need to do is take the perimeter and cube it. So what's 1 cubed? 1. So 1 foot cubed is equal to what's 12 cubed? Well, I don't know that one off the top of my head. I'm going to go to my calculator. 12 to the power of 3. 1,728. So this is 1,728. So there, we now have a volume relationship between feet and inches, even though it wasn't on our list. If you remember these two guys that are right here, that will help you out. If you know the original perimeter ones, which if you look on our conversions, we have those, to get the area conversion, all you got to do is square the perimeter one. To get the volume conversion, all we got to do is cube the perimeter. So now we have right here a unit fraction that I can use to convert my feet cubed up there to yards cubed. So we are going from 32,400 feet cubed to yards cubed. You have your relationship right here. Remember that the guy that we're getting rid of goes on the bottom. Feet cubed, the guy that we want, goes on top. Yards cubed. So, on bottom goes the 27. On top goes the 1. So all we need to do is take 32,400 and multiply that by 1/27. So take this 32,400 times alpha y equals 1 over 20. I didn't put the 1 in there for some reason. 1 over 27. Enter. There's how many yards cubed we have. Okay? So 1,200 yards cubed. There's step 2. Okay? We have converted from feet cubed to the yards cubed. Because in our problem, we need to know the yards cubed because that's what our trucks are going to be measured in. Okay? So the last step is find the cost. Now this one's a little bit more. We can't just take 35 times that number because my truck cannot hold 1,200 yards cubed. Each truck holds only 10 yards cubed. So what you first need to figure out is how many trucks do I need, which is basically figuring out how many times are we going to load the truck. Come back. So we have 1,200 yards cubed. Each truck can only hold 10 yards cubed. So what you need to do is take that number and divide it by 10. If you take 1,200 and divide by 10, you get 120 loads. We will have to fill a truck 120 times to ship out that dirt. So how much is this going to cost us? This is where we now do the multiplying of how much it was per load. And it was $35 per load. So we'll take 120 times the 35, and that will be our answer. That's how much it's going to cost us to get rid of all the dirt for our swimming pool. 120 times 35. And so the grand total is $4,200. $4,200. That's how much it's going to cost us to empty out the pool. Again, just like all the other stuff. First, you had to find the volume, then you converted it, and then down here, you had to do just a little extra manipulation, but you found the cost. That was the third step. So again, you're going to see that in this section, just like what we saw in 10.3 and 10.4. Whew! All right, moving on. And then, again, they're going to give you all these problems where they give you pictures, and they want you to find the volume of the figures. So what kind of figure do I have here? We have a pyramid. So what is the volume formula for a pyramid? Pretty straightforward. V equals 1/3 big B times H. Remember, big B is all about the base area. What is the base of our figure? It's this guy. And it is 52 by 52. So that means the base area is all about the area of a square because it's the same. So find big B, figure out up here what your H is, which I hope you can figure out what your H is because I only gave you one number. That's after the 52, and all you got to do is multiply all that stuff. What's the area formula for a square again? S squared, or you can call it length times width, or base times height, little b times h. Okay? So go ahead, find me the volume of this. All right, so if we start figuring some things out. So big B is equal to the area of a square, which is S squared. So our side lengths for our square are 52. So I need to know what is 52 squared. So we go to our calculator. 52 squared equals 2,704. So that's our big B. If you look up here, I talked about this earlier. You have two lines here. we've got this guy in here, and we've got this guy that's out here. Remember, the height that we want, the guy that we want over here, this little H, is the one where Indiana Jones drops to the inside. He does not slide down the outside. So which color is the inside? And that's the blue one, which is the only number that's left. Hint, hint, weird, weird, nudge, nudge. So all we got to do now is plug into our formula that's up here, and we'll take 1/3 times our B, which is 2,704, times our H, which is the 256. So our volume is equal to 1/3 times 2,704 times, I believe it was 256. Let me scroll up and make sure on that. Yepers. So go to your calculator, let it do its work. And don't forget the label in the end. So alpha y equals 1/3 2,704 and 256. Let me double check that 2,704. Again, I keep forgetting. Yeah, it's good. So all we got to do now is hit enter. And there is the area, or excuse me, volume of our pyramid. 692,224 all over 3. But again, that's a weird answer. 6,900 and what 20 or 6,900 or 6,000. Gosh, blah, word vomit today. 100 or 692,224. 692,224 all over 3, and that would be meters cubed. But again, they'll probably have you round on this assignment to 2 decimal places. So we actually want to go to our calculator. 692,224 divided by 3. I'm missing a 2. Let me add that back in. There we go. Hit enter, and now you can make sure that you round correctly. So really, the volume of that rounded is 230,741.33 meters cubed. 230,741. 230,741.33 meters cubed. Okay? Again, you just plug it into a formula, kicking me out an answer. Nothing cray-cray. So do it again. Figure out what shape you have, run the formula. All right, so if you look at this, the volume for a cylinder is pi r squared h. Okay? What's cool about this, you have everything you need. This is your R. This is actually your H. Now, I know what you guys are like, Mr. Armstrong, that height is not going down the middle of it. Well, okay, let me ask you this. If this length is 9, from there to there, if I drop a line down in here, how much is that? That's also 9. So they're actually the same. Okay? So even though this 9 is on the outside, it's the same as if it was in the inside. So all you got to do up here is plug in. Go ahead, pause the video, give it a shot. So when you plug in, pi r squared, well, that's 9 squared. Sorry, not 9 squared. That would be 10 squared. And then they want it multiplied by 9. And again, just like in the last section, 10.4, to this section, they'll want your answer 2 ways. They'll want one of them where you leave pi alone, and then they will want one where you actually use pi and round to decimals. Maybe 3, maybe 1. Just make sure you read those directions. Let me rewrite the word decimal correctly. Okay? So let's get the exact answer. So all you have to do to get the exact answer, where we leave pi alone, is square and then multiply with the radius. Quit moving. So 10 squared is 100, and 100 times 9 gives us 900 pi, and then our label will be yards cubed. You don't actually have to have the S on that. You can just put the yard cubed. Okay, it's all the same. So there's the exact answer. If you want to get the other one, go to your calculator, type in 900, slap the pi beside it, hit enter, and round to 2 decimals. So 900 second pi, hit enter. So rounded to 2 decimals would be 2,827.43. 2,827.43. 2,827.43 yards cubed. Don't forget that label. Everything has labels in this unit. Everything. And that's going to be the same thing that happens in the next module as well, too. When we get to module 3, everything has a label. Everything in module 2 has a label. All right, let's finish up. I think we're on that. Oh, nope. We'll come. Yeah. Let's talk about this one. So this one, the word problem is a little lengthy because I just made up my own. So I just want you to know that I'm going to take all of you guys out, one class or another, to Twisty Treat down the street, the one that's over here by Liberty High School, okay? And I'm going to take you all out in my brand new Stretch SUV limousine, okay? It is brand new. I take good care of this thing. I love my Stretch SUV limousine more than I love my kids. I'm just kidding. I love my kids a lot. I don't really have a Stretch limousine SUV. This is just for fun. And then I know some of you got your hopes up now. Am I really taking you to Twisty Treat? No, I'm not taking you, but it's just for the problem. So here's the thing. Because I love my limousine more than anything, and I'm going to buy you ice cream, you cannot eat your ice cream in my car. Okay, well, in my limousine, it's not a car. Say, you can't eat your ice cream in there. So that means you have to wait until we get back here to campus before you start eating that ice cream. I don't care what you say. Okay, you are not eating in my Stretch SUV limousine. So what I want to know is if I buy you because I'm not cleaning up ice cream in my car. But just so you know, we live in Florida. It's hot outside. So that ice cream is going to start melting as soon as we get it. So if I'm having you ride in my car, you can't eat your ice cream. Your ice cream is melting. And if it drips in my car, it's going to be me and you outside, fisticuffs. Okay? Pack a lunch. So I want to know, if we buy this ice cream and it melts, will it drip everywhere in my car? Okay? So will it drip everywhere in my car? And I have done some research, and I know that at Twisty Treat, that the ice cream, okay, the ice cream scoop that you have on your ice cream, it has a radius of 1 inch. And the cone is 5 inches tall and has a radius of 1 inch. Okay? So I want to know, if I buy you that ice cream, one scoop that has a radius of 1 inch and a cone that has a radius of 1 inch and is 5 inches tall, is your ice cream going to drip in my limousine and we're going to have to fight about it? Because I ain't cleaning. So, first thing I would tell you to do, draw a picture of this. You have an ice cream that is a sphere. Okay? There's our sphere. That's your scoop of ice cream. You know that it has a radius of 1 inch. Over here, cones, exactly as it sounds, ice cream cones. There's my ice cream cone. It is 5 inches tall, and it has a radius of 1 inch. So the first thing you need to do is you need to find the volumes for these. go ahead and do that. Because without the volumes, I'm not going to know whether I have to start beating all of you up because you dripping ice cream in my car, or everyone's going to be cool and we're going to have ice cream and my car's going to be clean. Excuse me, my limousine's going to be clean. So first, find those volumes. And go. So hopefully you paused that video and you started working on volumes. So the volume formula for a sphere, as I told you earlier, is 4 divided by 3 pi r cubed. So all we have to do is plug in our radius, multiply it by the 4/3, and then multiply that by pi. We don't want the exact answer to this. I need the decimal answer. Okay? So if I plug in my radius, which is 1, so all I need to do is go to my calculator, plug this in, and figure out what I get. Let's go ahead and round this to 2 decimal places, even though I didn't say up above. Okay? So let's go in the calculator, and let's take alpha y equals 4/3, put the pi next, and then a parenthesis 1 to the 3rd power. Hit enter, round to 2 decimal places. What do we get? 4.19. 4.19 inches cubed. So that ice cream scoop has a volume of 4.19 inches cubed. Let's find the volume for the cone. If you remember, the formula is 1/3 pi r squared h. So let's plug in our numbers where they go. So 1/3 pi r is 1 squared. Your h is 5. So we go to our calculators, we plug this in, and again, round to 2 decimal places. So alpha y equals 1/3 second caret key, which gives us pi. We've got a parenthesis with a 1 squared, and we got a 5. Okay, or if you want, you can put the 5 in parentheses as well. Doesn't matter. Hit enter. There's the volume of my cone. 5.24. So going back, inches cubed. Okay? So, will I have to worry about your your ice cream messing up my ride? And the answer is no. Everyone's good. Everyone's getting ice cream. You all get a ride in the SUV. No one's getting beat up. The reason being, because as long as my cone volume is bigger than the scoop volume, that means as it melts, the scoop will be contained entirely in the cone. Because my cone can hold a lot more cubic inches than what the scoop was made up of. So since the cone volume is bigger than the scoop volume, we good to go. Let's go get some ice cream. All right. And now that leads us back to the surface area that I was talking about earlier at the beginning, but I don't know why I talked about that one. You only have to know 2 surface area formulas, and that is the rectangular prism and the cube. And again, I showed you those pictures. So up here, we're talking about like 1 through 3. You have to know these the surface area formulas for these. Okay? So let's talk about them. When we talk about surface area, where I didn't talk about this earlier, but when we talk about volume and surface area, here's how I think about volume and surface area. Volume is about being able to pour liquid inside the shape and fill it up. That's what volume is all about. How much space do I have inside the shape? Surface area is about wrapping a present. How much wrapping do I need to perfectly wrap this shape? So that's what surface area is about. It's all about basically wrapping the outside. So one way to think about surface area, and when you first learn surface area, is that if you found the area of each surface and added it all together, that was the total surface area. But because we're talking about prisms and cubes and things like that, we actually have a formula for these. Really, really easy formulas. Okay? So, I mean, if you want to go back to your old way of finding surface area, if you find the area of all the faces, which there will be a total of 6, so you find those 6 areas on these shapes and add them all up, you get the surface area. Or you can just run the formulas, and here they are. When you look at a prism, you are actually finding the surface area of 6 sides, okay? Or you're finding the area of 6 sides, and 2 of those sides match for every face. So that's what you see up here. There are 2 faces that are made up of the height and the width. There are 2 faces that are made up of the height and the length. There are 2 faces that are made up of the width and the length. So if you take 2 times the height and the length, plus 2 times the height and the height and the width, plus 2 times the width and the length, and add all that up, you get your surface area. For a cube, because all the faces are the same, if you find the area of one of the faces and multiply it by 6, you've got the surface area. So all I'm asking you to do is to be able to run these 2 formulas. That's all you got to do. That's all that's left in 10.5. Can you find the surface area of a prism or a cube? Okay? And I already taught you how to recognize a cube. So let's get down to it. Here's a shape. Is this a prism or a cube? And you are correct. It is a prism. The reason why it's a prism is because all the numbers are not the same. If all the numbers were the same, it would be a cube, and I would run the cube formula. So what I need to do in this is I need to run the surface area formula that says I'm going to take 2 times the height and the width, plus 2 times the height and the length, plus 2 times the width and the length. So if you look up here and start labeling things, the 5, I'm going to call that the length, because that's the across the front of the bottom. The side right here that's going backwards, I'm going to call that the width, and the 6, I'm going to call the height, okay? Because it's the vertical length. So if you look at these 2, you can call this the width, you can call that one the length, it doesn't really matter, you'll get the same answer in the end. It's like dealer's choice. So all I got to do is plug those numbers in where they go. Again, all this is plug and chug, okay? So 2 times the height, which is 6, times the width, which is 13, plus 2 times the height, which is 6, times the length, which is 5, plus 2 times the width, which is 13, times the length, which is 5. So all I got to do is do some multiplying and add all those numbers up. Or just go to your calculator and just put it in the way you see it. So 2 times the length, the height, and the width, which was 13. I think that's the first guy. Yep. And then we'll have 2 times 6 times 5. So plus 2 times the 6, which is the height, times the length, which is 5. Plus 2 times the length, which is 5, times the width, which is 13. I can put that entire equation that I just wrote there a second ago in my calculator, and all I got to do now is hit enter, and I know the answer. So the surface area of that prism that we just looked at is 346, and the label being inches, and since this is area, it's squared. 300 and, what did I say? 46. Again, it's all about area, so it's inches squared. There you go. That's what your last couple problems will be. Find me the surface area of either a cube or a prism. And that, pretty sure, let me double check. Yep, that is all of 10.5. Good luck in this module. You've got everything you need to know. Get them all done.